Welcome to the video on integer exponent laws and logarithms. First, we're going to talk about multiplying exponents. So when multiplying numbers or variables with exponents, you're going to add the exponents together. But in order to do that, the base must be the same. So here for this first one, we have x squared times x cubed. So the base for both of them is x. So we'll keep the base, and then we'll add the exponents. So 2 plus 3 is 5. So x squared times x cubed equals x to the 5th. Now we have 5 to the 5th times 5 to the negative 3rd. We have the same base, so we'll keep the base, and then 5 minus 3 gives us 2. So we have 5 squared, which is 25. Now we have 2 to the negative 1 times 2 to the 10th. We'll keep the base. Negative 1 plus 10 is 9. 2 to the 9th, which equals 512. You can notice here the bases are not the same, so we can't multiply them together the way we've been multiplying the other ones. We do know, however, that 3 squared is 9 and 2 cubed is 8, so 9 times 8 is 72. But you can't just multiply and add the exponents. Next, we'll talk about dividing exponents. When dividing numbers or variables with exponents, you're going to subtract the exponents. And also, like with multiplying, the bases need to be the same. So x to the 5th divided by x squared, we have the same base, so our base is x, and then we do 5 minus 2, so x cubed. 5 to the 5th divided by 5 to the negative 3rd, we have the same base, which is 5, and then we do 5 minus a negative 3, which is 5 plus 3, so we have 5 to the 8th, which equals 390,625. 2 to the negative 1 divided by 2 to the 10th, we have the same base of 2. Negative 1 minus 10 is negative 11. So 2 to the negative 11th equals 0.000488, and then some other numbers. For this last one, we have 3 squared divided by 2 cubed. And once again, we can see these don't have the same base, so we can't solve it like we've been solving the other ones. You would just have to do 3 squared divided by 2 cubed, so you would do 9 divided by 8, and that would be your answer for that one. Next, we'll learn about what to do when you have an exponent raised to a power. So when raising a number or variable with an exponent to a power, we're going to multiply the exponents. And with this, you need to make sure to raise everything in the parentheses to that power. So for x cubed squared, we have x, and then we'll do 3 times 2. So it becomes x to the 6th. 3 squared squared is 3 to the 4th, because 2 times 2 is 4, which equals 81. Two x cubed cubed is the same as 2 cubed times x cubed cubed. So 2 cubed is 8, and x cubed cubed is x to the 9th, because 3 times 3 is 9. Two cubed to the negative 4th is 2 to the 3 times negative 4, so 2 to the negative 12th, which equals 1 over 2 to the 12th, which is 1 over 4,096. Now we'll learn what to do with negative exponents. So a negative exponent can be made positive by bumping it to the denominator or numerator. So if it started as a negative exponent in the numerator, you bump it to the denominator to make it positive. And if it started as a negative exponent in the denominator, you'll bump it to the numerator to make it positive. So for 2x to the negative 3, we'll take our x to the negative 3 and bump it down to the denominator to make it positive. So it becomes 2 over x cubed. For 4 over 5 to the negative 3, we'll take our 5 to the negative 3 and bump it to the numerator. So we have 4 times 5 cubed, which is 4 times 125, which equals 500. 9 to the negative 2 is the same as 1 over 9 squared, which is 1 over 81. And then 1 over 3 to the negative 2 is the same as 3 squared, because we'll bump it up to our numerator. So that's 9. Next, we have exponentials and logarithms. So an exponential is this one right here, a to the x equals b. So this is the same as log base a of b equals x, as long as b is greater than 0. So if you have a to the x equals b, we can turn this to a logarithm by taking our a and making it the base of a log over here. So this x would come down, and you'd get equals log. The a becomes the base of the logarithm, and then b is the argument of the logarithm. So x equals log base a of b. And then you can take this log base a of b equals x and turn it into your exponential by taking the a and using it to bump the x up, and you get a to the x equals b. So we'll try that with some of these problems. So 2 squared equals b. That one's pretty easy. You just get 4 equals b. 4 to the x equals 64. You would take this 4 and make it the base of a logarithm. So you'd get x equals log base 4 of 64, which you can enter into your calculator by going to math, log base, and then entering 4 for your base and 64 for your argument. So this should give you that x equals 3. You can also make it so that you have the same base. So 64 can be written with a base of 4 if we change it to 4 cubed. So if 4 to the x equals 4 cubed, we know that our exponents need to be the same, so x has to equal 3. For number 3 here, we have a cubed equals 27. So we'll take cubed root of a cubed equals the cubed root of 27. So then we get a equals 3. For number 4, we can solve for b by taking the base of the logarithm and making it the base of an exponent on the opposite side of the equal sign. So we get b equals 3 cubed, which equals 9. For number 5, we have log base a of 81 equals 2. So we can take our a and make it the base of an exponent. So we get 81 equals a squared. So to solve for a, we need to take the square root of both sides. So the square root of 81 is the square root of a squared, which means that a equals 9. For number 6, we could just enter the log base 2 of 32 into the calculator to solve for x. But the other thing you can do is take your base and make it the base of the exponent. So we have 32 equals 2 to the x. And we can solve for x by finding out what 32 would be with a base of 2. So we get 2 to the 5th power equals 2 to the x. And since they're the same base, we know that x equals 5. Next, we have Euler's number and natural logs. So Euler's number, which is the letter E, is approximately 2.718. And the logarithm with a base of E, with a base of Euler's number, is the same as what's called a natural log of x. So this is the natural log. So our log base E of 3 is the same as the natural log of 3. And our natural log of 5 is the same as log base E of 5. What's important to note is that the natural log of 0 does not exist, and the natural log of 1 equals 0. So there are several different applications for natural logs, logs, and exponentials. In chemistry, they use logarithms for the calculation of pH and buffer solutions. The pH of a solution is calculated by taking the negative logarithm of the hydronium ion concentration. In the Richter scale, the scale used to calculate how strong an earthquake is, The logarithm of the energy released is equal to 11.8 plus 1.5 times the magnitude of the earthquake. Finally, in the decibel scale, the decibel is equal to 10 times the logarithm of the power out divided by the power in. In summary, when multiplying with exponents, as long as they have the same base, you can add the exponents. When dividing with exponents, you subtract the exponents. And when raising an exponent to a power, you'll multiply the exponents. With negative exponents, you'll bump them down to the denominator if they're in the numerator, and you'll bump them up to the numerator if they were in the denominator. And that's how you make them positive. We also learned that a to the x equals b is equivalent to log base a of b equals x as long as b is greater than 0. And the log base e of x is equal to the natural log, or the ln of x, where e is Euler's number, which is approximately 2.718. Thank you so much for watching, and we'll see you on the next one.